Hello Math 152 students. In this video, we'll take a look at another example in TIN 2 that is similar to our La Quinta and Hampton Inn example and try to investigate whether we can proceed with our hypothesis test. So let's take a look at TIN 2 number 14 in your textbook. They tell us the following data represent the daily rental for a compact automobile charged by two car rental companies, Thrifty and Hertz, in 10 locations. Test whether Thrifty is less expensive than Hertz at the alpha equals 0.1, or we could say 0.10 level of significance. So just be careful that you don't write this down as 0.01. Here, it's less common to see that 0.10, but we can still see it. Note, a normal probability plot and a box plot of the data indicate that differences are approximately normally distributed with no outliers. So this note indicates that we're going to be able to proceed, but I want us to check this before we get started. So let's take a look at our data set, and I'm going to go ahead and pull it up in StatCrunch. It should pull up automatically for us. And the claim was that Thrifty is less expensive. And as we're looking down, notice Thrifty is more expensive than Hertz in our first example, but it looks like for a lot of the other ones, we are a little less expensive. Notice in Pittsburgh, that's not true. Phoenix, that's not true. New Orleans, that's not true. Or in Minneapolis, it's not true. So my first impression of this problem, if I go back and read, test whether Thrifty is less expensive, and then I look at the data set, I'm going, there's several scenarios where it's more expensive. I don't really think that the researcher got it right. But what can actually happen? Let's say you as the researcher make a prediction and you gather the data. Sometimes, just like your projects, your data may not support your hypothesis, and that's okay. We can still run a hypothesis test and check our initial hypothesis, even if after quickly looking at the data, we realize that it might not be correct, which I think is going to be the case here. So rather than just saying, oh, that's not right, let's scrap it, we want to get a p-value, make our decision. So, just like the previous example, we have 10 pairs of data. Notice we have it paired geographically, similar to the hotel example, because in different cities, we might have different rental prices that are based on the geographic location. Notice the first thing I want to do is go ahead and compute those differences. So hit compute expression. I'm going to build, and I'm going to do Thrifty minus Hertz. Now, when you're thinking about the order of your subtraction, you can subtract in the order that you choose. You don't have to do first minus second. I like to do first minus second in this case, and then think about how my hypothesis is stated, whether that's a less than, not equal to, or greater than. So I'm just going to do first minus second. And if we reversed and did Hertz minus Thrifty, we would just have the opposite signs. So we added a new column. And notice what this is telling me. If I subtract, this is telling me Thrifty is $2.82 more expensive per day in Chicago, but in Los Angeles, Thrifty is cheaper. So if Thrifty is cheaper, I actually see negative differences. So going back to my context here, when I set up my null and alternative, that will make a difference. Thrifty being less expensive means that when I subtract this one minus this one, I would expect to see negative numbers if Thrifty is cheaper. Now, keep in mind, Thrifty is cheaper in several, particularly Orlando, we see the biggest difference, but notice Hertz is cheaper in other scenarios. So we're not seeing a lot of negative differences that would support our hypothesis. All right, so before we get into the test, let's just quickly look at our QQ plot of the differences. Notice it looks approximately linear. Maybe these 2 points give me a little bit of pause, but we want to back it up and look at the box plot. keep in mind that small departures from normality in our QQ plot that we see here are tolerated okay, but it's really that box plot that's going to stop us. In other words, outliers in a small data set are going to be a big issue. Make sure you use your fences. Draw these boxes horizontally. And it looks like we're good to go. Part of what was going on in this one is we have some large differentials that are negative where Thrifty was cheaper, but we also have some large differentials that are positive where Hertz was cheaper. So in other words, we kind of get some balance here. We have some in the middle, but we don't actually have any outliers, meaning we can run our test. So I want to take us back to our slide, do a little bit of the setup, then we'll come back and get our p-value. So in this case, if there was no difference between the two rental companies, I would expect those differences to be 0. So mean differences equals 0 is my null. And I like to specify somewhere in my problem the way that I'm subtracting. So for us, we did Thrifty minus Hertz, so that when you're reading this difference less than 0, this is another way of saying, in this case, Thrifty less than Hertz. So that if we were subtract over and we had the difference, Thrifty minus Hertz, that would be less than 0. So negative numbers, like we said in that third column, indicate that Thrifty is cheaper. Then we have our level of significance of, forgot to change this, actually 0.10, 0.1 in this case, and we're ready to find our test statistic and p-value. We know our conditions check, and we can go in and ask StatCrunch. Go to your t-stats and your paired. So keep in mind here that for paired means, we're going to use the t-distribution, similar to what we saw in chapter 10, and the paired option. Notice none of your other options here have the paired, so it makes it pretty easy to choose the right one. We have my sample 1 is Thrifty, sample 2 is Hertz, and we can go ahead and set up our hypothesis test with our less than and compute. Notice my p-value here, 0.33, 0.34 approximately. This is not smaller than my 0.10. It's a relatively larger p-value. I would say this is not small. So when I get ready to interpret, I am not smaller than my alpha, and I'm not going to be able to reject the null and support the alternative. This goes along with what we were saying in the beginning. This isn't supporting the claim that we have negative differences. Okay, so hold on to this idea. I want to show you one other shortcut. We had already checked our box plot and QQ plot, but there is an option to do this at one time. If you go to your t-stats and your paired, you can ask StatCrunch to save your differences, and it will compute the subtractions for you. It will always do it in the order sample 1 minus sample 2. Then we have the less than, and you can ask StatCrunch to do your box plot and QQ plot as part of your work. So if you hit compute, notice I'm getting the exact same p-value. Notice over here it put my differences, so it sort of does it all in one step. And then you have your box plot, your QQ plot. All I did here was mark the mean, which is, notice, different than our median in this case. So one reason I like to do it the other way first is to get a sense of these differences. Really seeing not too many negative values helped me understand that Thrifty was not that much cheaper for most of the places. Then the other reason is sometimes when you do the option with your graphs embedded, you forget to look at them. And in the case of our previous example, we might have forgotten to check and we might not have noticed that we had an outlier. So again, two options here. You can manually create those differences asking StatCrunch to do that using the data compute command, and then create your QQ plot and your box plot separately, or you can ask it to do it all in one. Just make sure that you check to make sure things look good before you interpret that p-value. So let's wrap up this example. We said that the p-value is greater than our level of significance. I apologize here, I forgot to change that to 0.1 or 0.10. So we cannot reject the null hypothesis, and we cannot support the alternative. There is not sufficient evidence to conclude that Thrifty is cheaper than Hertz. And again here at the 0.10 level of significance. So that'll wrap us up for 11.2. Most of the examples that you're going to see, they will give you the raw data. In fact, when you're looking at the StatCrunch option for your paired, so t-stats paired, you don't have a with data and with summary. You have to have the data into StatCrunch in order for it to run your test. All right, so in our next one, we'll pick up with 11.3, where we do not have paired data, but we have two samples and we're looking at means.